Good morning, everyone. Welcome to the Best Practices and course, NRIS Best Practices course. And we are glad to have you here. My name is Tanya Pushpadas, and I work at University of Bergen and NRIS. NRIS is a collaborative organization of five organizations: University of Bergen, University of Oslo, University of Tromsø, NTNU, and Sigma 2. Before I start the logistics, I would like to remind you that we are recording this training event. So if you don't want to be recognizable, please feel free to switch off your camera if you haven't done it already. And the first and foremost thing that we use the collaborative document, and link is based on the chat to interact during this course. And you can type your questions here, and you find the general information on top of this page. So how you do that, how you do to edit this page, you see the top left corner, there is a pencil or pen icon, and you can edit it here, pressing here, and you can edit, always ask question on bottom of the page. Here we already asked an icebreaker question: what would you like to get out of this course? Please add your answer here, and while I go through the further logistics. As I mentioned, you can find general information on this page. This document is linked here as well, and the course page, you can find it here. And for our upcoming event, next week we have a Q&A session with the NRIS staff. So the details are linked here, or you can subscribe our channels to get notified of our future events, and also the NRIS documentation. And slides for today's presentation are you can download it from here, that's linked here, and the schedule also. And last but not the least, we follow the Carpentries Code of Conduct. Basically means that being respectful to each other. If you need to contact me you can contact me if you find anything regarding this, and we expect that everyone follows this. And this course is collaboratively done by my NRIS colleagues from different sites, and as you will be introduced to them in a short while for today as today's instructors. And you can find we have added your wishes we asked during the registration form, and most of this will be covered during these courses, and furthermore we will take care of it in the upcoming training events or Q&A session. So you can always contact us regarding training. So at NRIS, we jointly operates the national HPC and storage services and provide support and training like this event. So without much delay, I will give this Zoom dice to my colleague Einar, who will talk about the NRIS infrastructure. And thank you and welcome again, and enjoy your course. Over to you, Einar.
Yeah, thank you, Tanya. I will try to share my screen.
Yeah.
I hope this is working. Do you see anything?
Yes.
Excellent. So I'm going to give you a brief overview of the infrastructure that we are running in the NRIS and in collaboration with Sigma 2. My name is Einar Næss Jensen. I work at NTNU in the IT department. I am team leader at the NTNU HPC group, and I'm also team leader for the NRIS infrastructure. I have been doing HPC work for the last 14 years, and also some IT support quite a few years before that. My background is media science, and I have also done some journalism and informatics and some history. Wait, sorry. I just have to ask, you can see that I'm switching slides, right? Yes, excellent.
Yes.
Thank you. So, the current setup is Sigma 2 is the owner of all the facilities and the hardware that we are supporting. And currently, our main facilities are Trondheim, Tromsø, and Lefdal mines. And I put Lefdal mines on the top because that is our new main facility for all hardware, or at least for the larger hardware. But that this is a work in progress, and probably we will not see a complete move of all Sigma 2 owned hardware until I would guess sometime late in the 2020s. In Tromsø, we have the From HPC system, and we have also the NIRD and the NIRD storage and the NIRD toolkit, or the service platform as it was previously known as. In Trondheim, we have 2 supercomputers. We have Saga, which has some specific characteristics, and we have a larger system, Betsy. We do also have a mirror of the NIRD storage system, and also a mirror of the NIRD toolkit, or the service platform. So in addition to this, these systems, we also have in Oslo the TSD that is not owned or run by Sigma 2 or NRIS, but it's still a part of the services that you can apply for. And another big system that we are collaborating with is or we are even partner with is the Lumi system in Finland, which is part of the exascale the Euro exascale systems. So the basics for one thing is the systems themselves, but we do have to get everything facilitated for you who are using the systems. There are a lot of network equipment, and it's both in Tromsø and in Trondheim. Yeah, we can have a look at the Trondheim because it's a little bit more complicated, because we have one more HPC system. So we have the Uninet gateways, and we have several layers of switches before you get down to the actual login servers for the HPC systems, or for the NIRD logins. So this is sort of how our systems more or less was supposed to be. It is not entirely like this today. This was sort of the ideal description of how everything should be working, and in particular it was this, you see those red arrows with the georeplication and copying between the two NIRD platforms in Tromsø and Trondheim. And as you may or may not know, it hasn't always worked exactly as we have wanted it to be working. So that we hope that this will change for the better in the future when we get a new data center in Lefdal Mines. But it still gives a very good view of how our systems looks conceptually. So in Tromsø, the NIRD storage is connected directly to the Fram supercomputer. So you can access Fram project files on the Fram supercomputer, and it is the same thing in Trondheim, where you can access the NIRD Trondheim storage on Saga and Betsy. The NIRD project folders are only available on the login nodes, or in special cases it can be also been reached on pre-proc or post-proc compute nodes. In an ideal world, the NIRD project directories would also be available on the compute nodes. Today, this is not practically possible, but again, when we are moving to a new data center, we have the opportunity to try this again, to have project directories available on the compute nodes. But we will see what the future holds. It's things are in flux. We will see. Conceptually, the network structure as it is in the Lefdal Mines, it is similar to what we have already today. But we have here in Lefdal Mines, we will have the opportunity to have a more tightly coupled network between the HPC machines and the NIRD storage facilities. So very short about the current HPC systems. Fram was procured and set in production in 2016-2017, and Saga was procured and set in production in 2019. And then we have the very big machine Betsy, which was set in production in late 2020. And unfortunately, only the Betsy machine has this nice graphics on the front. I personally, I wish that we had some sort of more marketing on our stuff, because I think it's very cool. If you happen to be in Tromsø or Trondheim, I'm sure if you want to see the supercomputers, I'm pretty sure that would be quite okay. Just make contact with us, so we can probably arrange something. So we have, as I said, three different systems, and they are somewhat different. They are all x86 systems, so that is the common theme, but they vary slightly in size and capacity, different types of capacities. The Fram supercomputer has around 1,000 compute nodes and 32,000 CPU cores. It is a Lenovo system, and it has Intel CPUs with the 32 cores. We do also have some huge nodes with 6 terabytes of memory. The performance is around 1.1 petaflop, and we have a disk capacity of 2.5 petabyte. The network is in InfiniBand, which is EDR 100 gigabit, and with the file system is Lustre. The Saga supercomputer is HPE system, and it has, I see now that my slide is wrong. It is not 10,000 cores, it is 16,000 cores. And the number of nodes is also wrong. It is, we did an upgrade last year, so we have expanded. We are now around, if I remember correctly, 350 nodes, more or less. The CPU is also Intel CPUs, and in addition we have 32 NVIDIA P100 graphic cards. So that is the first generation of the Tesla cards. Performance is that it's also the wrong number. It is more or less 1 petaflop. The network is FDR InfiniBand, and the file system is BGFS. In addition to this, this Saga computer has local NVMe drives, and it is the only of our machines that has such capability. So that means that if you have some application that could benefit from using a local scratch file system, be sure to put that in your application, that you need a local scratch drive, because then this could be the machine for you. So the large machine, it's Betsy. This is a Atos Bull-Sikana system, and it differs from the two other machines in the way that this is not some off-the-shelf servers. So it's not something you can go to your average server vendor and buy. It has 170,000 cores, and the number of nodes are 1,300. and it is a AMD system. And each compute node has 128 cores. So it's everything is very tightly packed. The performance is rated to be around 6.2 petaflops. And we have, for the network, we have a combined 100/200 gigabit InfiniBand. The file system is Lustre, and some other interesting numbers is that the whole system draws one at full power. The system draws 1 megawatt, and each rack in the system, there are a total of 15 racks in the system, and each rack in the system draws around 84 kilowatts of power. So it's very, very tightly coupled machine, and very power dense, which means it's also very power efficiently. It is water cooled directly. Yeah, so when it comes to storage, we have the NIRS file system, and I'm not mentioning the local systems now that we have in Trondheim and Tromsø, because that is to be decommissioned during the next 6 months, probably. We are getting quite a substantial expansion in Lefdal mines, and it which is new this time is that we're also getting object storage. And if this is something you can, if you somehow can benefit from using object storage, that might be of interest to you. Yeah, so this is, I have some pictures here of what the storage on Saga, Fram and Betsy, what they actually look like. So what might be interesting is that Fram and Betsy is, it is the same hardware vendor, and it is only, I think it is 2 or 3 years between, and you see the storage density has increased substantially. When it comes to the networking on from Saga and Betsy, perhaps the main difference between these 3 machines are the network topology inside the machine. They are all running InfiniBand. That means that it has a very low latency network. But the way it is coupled together is very different. So Fram and Saga is more or less the same. Fram is a bigger machine, so it has one more level in the InfiniBand topology. But they are both a fat tree topologies. So the network structure is formed as a tree. And you can also see that the topology in the Saga is more loosely connected. When it comes to Betsy, it is using a more advanced network topology. in the case of BESI, it is called dragonfly topology, and the point of organizing the network structure in such a way is to have as few hops between any compute node to any other compute node. And the reason for organizing it in that way is to ensure that so that all compute nodes are treated equal in the network. There are other advanced network topologies, and for example, on the previous supercomputer in Trondheim, it was using hypercube topology. So all these different characteristics between the machines, it means that depending on what you apply for, what kind of resources you apply for, you will end up in a different kind of machine. So if you're asking for single core up to single node jobs, and if you use or have the needs for high IOPS on Scratch shared file system, or extreme high IOPS on node local Scratch file systems, you will probably end up on Saga. If you have need for single node to intermediate large jobs and somewhat high bandwidth on the Scratch file system, well, it will translate it into you need to read or write larger files. It is highly likely that you will end up on Fram supercomputer. If you are among the few that have need for multi-node up to very large jobs, and you need very high bandwidth and intermediate high metadata Scratch file systems, then probably BESI is where you will go. We do have the possibility to, if you for some reason have the need to have a very dedicated machine, we have the possibility to set up virtual machines for you. We have this possibility on the Fram supercomputer, and we have it on the Saga supercomputer. We might have it on the BESI supercomputer. We haven't, the infrastructure for us regarding virtual machines are not entirely ready on BESI. But if there is a need, we might be able to facilitate that. During the last 3 to 4 years, when we have been running, well, 5 years actually, we have learned some valuable lessons when it comes to our supercomputers. First thing is that currently the CPU and GPU market is very much in flux. It is very hard to orient, to get a clear grasp on what the future holds. We have learned the hard way that having a tightly coupled system to an externally operated storage system like the NRIS, it causes dependency problems. And so this is something that we have to think very, very hard about when it comes to the next supercomputer. What is very clear that we have learned is that low latency network is good. And it has been very good for us on all 3 machines. So this is probably something that we are going to continue with. Having different file systems with different characteristics is very good. Currently, on all our 3 machines, we do only have locally on the machines, we have only one shared file system. And we think that it would be better to have several file systems on each machine. We think that we have learned that the latest is not always greatest. So when we're buying or procuring systems, it might be a good idea to not aim for the absolutely latest when it comes to CPUs or technologies. It might be better to try to aim for something that has actually been in production for at least a year. But then again, it's not a good idea to aim for something that has been in production for 5 years, because that is already obsolete. We have learned that having the ability to expand the systems, that is very good. Having the ability to expand in a very easy manner is even better. We see that although we might not like the cloud very much, there is no way around it. The cloud is here, and it's for many specific purposes, it is a good thing to have. Currently, we do not have any kind of cloud bursting or cloud expansion on our systems from Saga and Betsy. We would very much like to have that in the future. And we think that we have a problem, and we think that we see a demand for modern GPUs in our systems, and currently we don't have anything. Locally at the universities, there are different degrees of availability for GPUs, and when we're talking about GPUs, we are talking about something that are strictly CUDA compatible. The Lumi system, which is a very large GPU system, does not have NVIDIA GPUs. It has the AMD MI250 cards. And what we see is that users ask specifically for NVIDIA GPUs.
Is there anything we have to take from HackM, the collaborative document?
Einar, in the compute nodes,
yep,
and internet access, do you have anything to add to that? Like, why is it restricted to access some sites from the compute nodes?
We see so we have it as it's our security policy that we do not allow direct access from the compute nodes to everything. It is as simple as that. We have on our previous systems, we have had some not so good experience when not deliberately necessarily that some users have by mishap try to access the internet or some internet sites from a lot of nodes at the same time. So there's that. We would like to restrict it to avoid such things. But if you have specific requests, everything is solvable.
So the special request should be right to support. That's what you mentioned.
Yes, that would be the starting point.
Okay.
Yes, and I would okay. So there's one thing that I haven't talked about very much about the service platform, and I would just like to point out that we do also have a lot of opportunities for running things on the service platform, or the toolkit as it is also called, just so that you are aware of it. Right?
Yeah, thank you, Einar. It's just, and the question 5, how should you download and upload a big database? Sabri, this is the bioinformatics database we have on the shared space.
Yeah, so on Saga, those are bioinformatics databases, because those databases are not the software that uses those databases are not parallel enough in the sense that they can't optimally use from or Betsy. So you are advised to use Saga when you access those databases. So they are set up on Saga. But there are other databases on cluster shared as well. The basic idea is that if it is something only for yourself or 1 or 2 people, you might well as download it yourself from a login node. But if you think it's a good thing for the community, then if you make a request, we can find a shared place and the staff can download it for you. So it's a case-by-case basis how to do this. But it's always we can come to an amicable understanding if you send a request.
Yeah. And thank you, Sabri. If it's only 1 or 2, then it's a best place to store this data is the project space, right? Because your home directory is not big enough to store this large kind of data sets.
That is a good point, Dania. So storing is another thing. Downloading is one thing, and we have to keep is another thing. So if you keep it on shared area, you will not be that will not be counted against your quota. So that's for the common use. So the common good. But if it is your group area, like let's say this NN9984K, for example, the course project use, you have similar course projects. So those projects folders, you could keep it in your project area, so the project colleagues could access. But it's only for yourself. Even you could get permission from your project and leave it there, because your home area is very limited. So you should not try to download a big file, big content in your home area. So and sharing home area with others is not recommended. So keep it, if it's something shared, place it in the project area, and make sure if you download it on your home area, when you, after moving to your project area, you set the correct group. That I think we will discuss little later on.
We have already discussed this last
yes,
last month's course.
Yes.
You had the
yes, and the other thing is some people download it on the work area, cluster work. because that's not counted against the quota. But you have to be mindful that that might get erased. So that's not a place to keep things. And in general, all the data storage partitions, the cluster partitions, which are parallel file system partitions, which can have access from compute nodes, are not for like data repositories, right? So this is like, if you have data repository, you should go for NIRD. So this is for input output data, short term storage, and that sort of thing. Yes.